Today, we're going to talk about the lesson overview of lesson 1.02, graphs of functions, functions and their graphs. One of our lessons that we're working on this week. So I got to get the other lessons up for next week too. So you'll have those by Monday. All right. So we're talking about graphing functions and what does that tell us and what does that show and all that good stuff. So let's recall the definition of a function is that, every x only has one y assigned to it. So when we have a graph, and let me put a graph. I've graphed a sample for us this morning. All right, so here's a sample graph. For this, graphically, we can tell it's a function because for any x value, there's only one y anywhere on the graph. Say for negative 1.67, there's only one y. There's not another y higher or lower that the graph crosses through. There's only one y for every x. So it's easy to tell graphically what a function is, right? It's got that vertical line test that we learned about earlier classes. You draw a line straight up and down, and it will only touch your graph in one location. So it's easy to tell a function when it's graphed. But we're going to talk about more things about functions. Like we need to discuss where's a function increasing and decreasing, right? Because we talk about all kinds of properties of a function right here. So if we look at this function, if we talk about where it is increasing and decreasing, we have two places that it is increasing. As increasing and decreasing, all goes left to right. So this graph is increasing for as far as it exists to infinity. It increasing as x comes up to 2. When it gets to 2, it stops increasing right there. The graph is no longer increasing at that point. At this point down here, it starts increasing again. So this graph increases from negative infinity to negative 2, not including negative 2. So we would use a parentheses, not a bracket. Negative infinity to negative 2, because at negative 2, it's no longer increasing. And it's increasing from 0, not including 0, we'd use a parentheses, 0 to infinity. So all those x's from negative infinity to negative 2 and from 0 to infinity, this graph is increasing. But in between there, from 2 to 0, it is decreasing. So there's only one place that we would define this graph as decreasing. So it's easy to look as the x's get larger, the y's get smaller. That's graphically how we tell that it's decreasing. As the x's get bigger, from it goes negative 2 to negative 1, the y's went down. I can get right on there. There it is. So the x increased and the y went down too. And again, from negative 1 to 0, the x increases and the y is still going down. But when we go from negative 2 from go to 0 to 1, the y's increase. So that's how you tell graphically. Graphically, we're going to tell it increases or decreases just by what do the y's do as the x's increase. All right. So other things we would look at when we talk about a graph would be minimums and maximums. Minimums and maximums. So when we look at a minimum or a maximum, we could have an absolute minimum or maximum. But in this case, we don't, because if we say, okay, what is the maximum for this graph that we're looking at? Well, the y goes all the way to infinity, right? As x is getting larger and larger and larger, it's going all the way up to infinity. So there is no maximum value for this graph. Also, that means there's no minimum value for this graph, because on the left side, as the x is going smaller, the y's are going to negative infinity. But we do have relative minimum and a relative maximum. We have those. A relative just means it's not the absolute minimum of the graph, because this one doesn't have an absolute minimum. It's just a relative, is the term we use, relative minimum. So a relative minimum for this means in this area, it's decreasing and then increasing. So that is a relative minimum at 0, -4. It's a spot during the graph that it's decreasing on the left and increasing on the right. So that makes that a minimum, but it's a relative minimum because we can find a number that's smaller. Like over here, this y over here is smaller than -4. So this is not the absolute minimum, but it is the relative minimum. Same thing with this maximum. This is a relative maximum. So while we would not define this graph as having a maximum, it does have a relative maximum. When x is -2, the maximum is 0. So keep in mind that when we're talking about minimums and maximums, sometimes we may just have a relative minimum, relative maximum, and we may have several of those. If this graph really has a lot of ups and downs, we could have multiple. In fact, I can change that and add some more right here. Let's look at this. So we'd say x plus 4 and x minus 3. And make it x minus 2. And now we're looking at it. Graph's getting all crazy here. But we have a relative maximum here. What's it? We have another relative maximum up here, and we have a relative minimum here, and we have a relative minimum here. We have multiple relative minimums and maximums, yet we still don't have just one minimum or maximum. All right, we have multiple. So different terms we're adding to our definitions here. We'll go back to our original graph here. Something easier to look at. All right. What other things do we talk about in this lesson? Oh, we talk about even functions and odd functions. All right, so even functions and odd functions. So with an odd function, it's up here, and it gives us a example of this in our text on Buzz. An even function or an odd function when graphing. All right, so an even function would look like a parabola type thing, or it could have another wave in the middle of it, but both ends would be going up. And on an odd function, you're going to have a look like that, where you have one going to negative infinity and one end going to positive infinity. And it gives us in our text a test to tell if something's even or odd. All right. So a function f is even if for every x in the domain of f, if you substitute negative x, you end up with the exact same as having positive x. So if you replace all the x's in the function with negative x and simplify it, you'll get right back to where you started. It's odd if you substitute a negative x in there and you end up with negative of what you started with. This is the test. We'll do that. Now let's look at one here. I'm gonna put an equation down, and let's see what it's talking about. Let's do f of x equal x to the 4th plus 3x squared plus 5. And we're going to test f of negative x. So that equals negative x to the 4th plus 3 times negative x squared plus 5. So now let's simplify this. F of negative x equals negative x to the 4th power, which means it's negative x times negative x times negative x times negative x. Negative x times negative x is a positive x squared. times another negative x is a negative x to the third times another negative x is now back to a positive x to the fourth. So that equals x to the fourth plus 3 times negative x squared. Negative x times negative x is a positive x squared. So that's 3x squared plus 5. So when we look at that, with negative x, we ended up with exactly what we had with positive x. So that tells us that this is an even function right there. An even function. So that's just a mathematical test we can use to see if a function is even or a function is odd. If we substitute that and we get something like this. So let's look, if we change this just quite simply, let's just make it as simple as x to the third. We'll just make it a simple equation. And we want to test this. What happens when we put f negative x in there? Well, that's 3 of these. Negative x times negative x is a positive x squared times another negative x is negative x to the third. It ends up exactly a negative of what you started with. Instead of f of x, we've got negative x. And even if we had a plus x over here, it would end up minus x. Every one of these would turn into a negative, which this would be the same thing. Since this says negative f of x, like the negatives out front, if we factor out a -1, this is the same thing as the original one. We can see that's the same thing as negative f of x, because f of x is that. Because we factored a -1 out of there. So in this case, f of negative x equals the negative of f of x, which tells us this is an odd function. Because it's the negative of f of x right there. So mathematically, graphically, we can see odd functions like that, or even functions. That could be upside down, right? Could be an upside down parabola, would be even. Odd could be reversed, where it's negative infinity on the other side, and positive infinity as it goes negative. But that's just the test that we use for that. Let's see. Symmetry. Let's talk about symmetry too, because that's another characteristic we're looking at. So let's take this graph away and let's give us another graph of y equals x squared. Let's make it that simple, right? Symmetry. So and it actually gives us a definition of symmetry in our text also. It says basically whenever there's a point xy on the graph, there's also a point negative xy. So if we have the point right here, it's not going to stay on there for me here. I'll put the point 2 comma 4. So we have the point 2 comma 4. That means if it's symmetric, we should also have the point negative 2 comma 4, which we do. If we have the point 1 1, we should also have point negative 1 1, which we do. So this one would have symmetry with respect to the y-axis, right? Because around the y, whenever there's a point over here that's an xy, it also has a negative xy. So this has symmetry with respect to the y-axis. We can also have symmetry with respect to the x-axis. Turn those off real quick. Let's take off these labels. Because if we had x equals y squared, this is the same situation, but now this has symmetry with respect to the x-axis. And we have the point 1 1 on there. So with respect to the x-axis, you should have 1 comma negative 1. Oh, not negative, as a point also. So we'll label that. So it should have an opposite y. Same point with an opposite y if it has symmetry with respect to the x-axis. So let's look at one that has symmetry with respect to the origin. Y equals x to the third. Got that label. So if we have the point 1 1, let's turn on the point. There it is. 1 1. If it has symmetry with respect to the origin, with respect to the origin, that means it's also going to have the negative values, the -1, -1. This is also known as rotational symmetry, right? Rotational symmetry. So symmetry with the origin means if it's this direction, it also has a point that's the same distance the other direction from the origin. When we did the x-axis, when it has symmetry there, it's the same distance from 9 to this point is the same distance as 9 to this point from the x-axis. So right there. So from -3 to +3, you have the same distance from the x-axis. All those points and its matching point on the other side is the same distance. Well, we have the same thing when you're talking about the origin. These are all the same distance away from the origin. There's a point matching distance the other direction, 180 degrees the other direction from the origin. Rotational symmetry. So 3 different types of symmetry we look at. Symmetry with the y-axis, symmetry with the x-axis, and symmetry with the origin. We know there's more. We could have symmetry around other lines. We can have symmetry across diagonal, y equals x. But this lesson, we're basically talking about those 3 primary symmetries. Put them all on there. The x-axis, y-axis, and with respect to the origin. Let's see. We looked at the relative minimum, relative maximum, or relative extrema. That's what they call them sometimes there. We looked at symmetry. We looked at even and odd function. That's in our lesson. Let's see. We looked at increasing, decreasing, and primarily just what a function is. All right. So that is a good rundown. Let's see if there's anything else that I had in here. Boundedness. One other thing it talks about is boundedness, about a graph being bounded. So let me pull up this paper again over here. If a graph is bounded, then it gives us some, let me bring this down here where it's a little closer. It gives us some example graphs in our text here. So boundedness. So if we look at this, it says not bounded above or not bounded below. That means there's not a maximum. So it's not bounded above and it's not bounded below. There's not a minimum. That graph keeps going. They didn't put the arrows on there, but it's assumed that keeps going. So it's not bounded anywhere. There's no limits. Bounded you can also think of that as like a limit. Is there a limit to it? Is it bounded anywhere? This is not bounded above because it keeps going up, but there's a boundary right here, right? Bound is like boundary. Nowhere is there a value of the graph that's any lower than that y value right there. It is bounded to be y's above that level and above. It cannot have anything. This one's bounded above. There's no y's exist on the graph larger than that one right there. There's not a larger y than that. And then this is bounded on both sides. You don't have a y less than that. You do not have a y greater than that. So this has bounded, or you can think them as boundaries. There's a boundary, you're bounded. Boundaries for the graph, right? Also kind of works like maximum and minimums. Maximums and minimums define the boundaries, right? That is the maximum for this graph. That is where it's bounded at. That is the boundary. Same thing. That's the minimum for this graph. That is where it's bounded at. That is the boundary because that is a minimum. So boundedness is another part that's covered in this lesson right here. So this does a really good job of when it gives you definitions, it's using the mathematical terms. It's good to get familiar with that. You'll see a lot of that in college. We'll start talking about the math language. And this is just for increasing and decreasing and constant. A function f is increasing on an interval if, for any 2 points in the interval, a positive change in x results in a positive change in f of x, which f of x is the same as y. So that basically means if you look at 2 points and the x goes up, a positive change, the x goes up, and the y also goes up, that's an increase. All right, so just break it down portion by portion. What's it saying? A function's increasing on an interval. Okay, so it means in an area for any 2 points in the interval. So if we look at 2 points in that space, a positive change in x, which means x will not is a positive change in f of x, which is y, right? Because we know f of x is also y. Same thing, decreasing. Any 2 points in the interval, a positive change in x is a negative change in y. And it's constant if any 2 points in the interval, a positive change in x results in no change, a zero change, right? So a positive, a constant, a positive change in the x results in no change in the y. The y stays exactly the same. So constant, increasing, decreasing, constant. But this is the math terminology. Learn to read the math terminology if you haven't done a lot of that before. Get used to the language. It will only benefit you as you move forward into college and those type of things. So, all right, I think that covers about everything that is in this lesson. Anyone have any questions on all of that good stuff we looked at? I saw several of you got in there and started to already work on the lessons for this week, so that's good. They're not due till Sunday, but some of you guys are already done with it. Some of you haven't. Some of you got in there and looked at Buzz a little bit, and that's good too. So, but if you have any questions, let me know. Let's see. Tomorrow is a B day, so we meet again tomorrow because this is still in the first 2 weeks of class. But after tomorrow, we'll start our usual virtual school schedule to where we will only meet on Tuesday mornings. And then the rest of the week, you just come if your grade is low or if you need help. You can have 100% in class and still come to class on Thursdays or Friday when it's a B day. Because I'll come to class at 7:15 and see if anyone's here. I probably won't stay an hour and a half if nobody's here, but I'll stay for a while and make sure that I'm here in case you're needing help with anything. But anyway, I will let you guys go then and enjoy the rest of your Thursday. We'll see you tomorrow.
Let's get out of here. Word to your multiples. Math.